Oh, I got one.
This paper covers the Pythagorean Theorem. You've learned the Pythagorean Theorem before. We're going to refresh your memory on it because it's going to get used in what's called trigonometry.
Left older, huh?
Well, you know what?
Call it!
First baseman, huh?
It's going to be used in trigonometry. The formula for Pythagorean Theorem is a squared plus b squared equals c squared. Can you tell me why I'm highlighting c a different color?
Because C is the hypotenuse.
C comes from the hypotenuse. A and B come from the legs, which means the sides that make up the right angle. Just remember that the restriction is the hypotenuse has to be C. The first thing you need to know is the vocab word Pythagorean triple. A Pythagorean triple means three numbers, when plugged into the Pythagorean theorem, make a true statement. For example, 3, 4, 5. If I plug 3, 4, and 5 into the Pythagorean theorem, I get 9 plus 16 equals 25. What's 9 plus 16?
25.
And that's a true statement. So that's called a Pythagorean triple. It came from 3, 4, 5. Another way to call it is a 3. Another way to talk about this without using the words Pythagorean triple is it's just referring to the numbers and saying it's a 3, 4, 5 triangle. When you say that, you're implying that if you plug 3, 4, and 5 into the Pythagorean theorem, you have a true statement. You do need to remember that the Pythagorean theorem only works with what type of triangle?
Right.
With right triangles. It only works with right triangles. You'll never be able to use it on non-right triangles. If you come right here to this chart, you're going to see where they've got 3, 4, 5 listed. If I took a 3, 4, 5 triangle and I dilated it by a scale factor of 2, it would get what? Bigger. And what would the lengths of the sides be? That used to be 3, 4, 5. They would be 6, 8, and 10. If you don't know how we got that, we simply doubled the 3, 4, 5. 6, 8, 10. If you plugged it into the Pythagorean theorem, you would also get a true statement. Okay, another Pythagorean triple would be the 3, 4, 5 triangle dilated by a scale factor of 3. So if you multiplied all those by 3, what would you get?
9, 12.
9, 12, 15. That's another 3 pretty numbers. When plugged in, will give you a true statement. Okay? The purpose of this chart is just to get you comfortable with these numbers. And I'm going to tell you right now that those are the most common ones. Look, you're going to see them a lot. And you're going to appreciate knowing the shortcut. Okay? I want you right now to finish the chart of the Pythagorean triples. If it was dilated by a scale factor of 2, if it was dilated by a scale factor of 3. Finish that chart right now. Fill in that chart. Is your chart filled in?
He's writing on my paper.
Hey, can you please not do that?
I'm giving you my answers.
No, dude. You write smiley faces on my paper.
There's not one even like eyeball on that page.
You're filling in the chart. Don't look up here until you're done.
No.
Yeah,
No, stop.
that's what I wrote. Thank you.
Are you coloring on my shirt?
This is 75? Yeah. Yeah, I don't know. You probably couldn't tell what it looks like. It did look like a 3, didn't it? That was definitely not a 3. That was a 2. I fixed it. Thank you. I have a master's in math, and there's times that arithmetic trips me up because I'm trying to make it harder than it really is. I'm guilty of that. Did you get the answers right? Okay. The point of this little section here is if I give you 3 random numbers and I tell you, hey, are these 3 numbers the side lengths of a right triangle? You would take them and plug them into the Pythagorean Theorem and see if the right equals the left. That's how you know if they are or not. So on your paper somewhere, and there's not a lot of room, so maybe go to the notebook paper down below it. You need to put this right here so that you know where this came from. So maybe go to the notebook paper and put that, the math that we did. We plugged 3, 4, and 5 in.
Pretty sure you're gonna have to write on that. What you just said, right? You just said right.
I don't think she did.
No, see if it'll factor. It's huge.
What did you mean by forms?
Oh no, you only do that if it's equal to 0. That only works when it's something times something equals 0. No, do the quadratic formula.
I'm here to tell y'all call.
Because you don't want to do.
I can't do that.
I don't know how do you do it.
No, because this is saying something times something equals 40, which means we have no clue what they are. It only works when it's equal to 0. All right, now open your paper up.
I'm not Mexican.
You need to move back over here.
Ever since he's came to sit by me, it's just been worse.
Open your flip book. Here's another type of problem that can be presented with Pythagorean Theorem. It can be used to find the missing length of a side of a triangle as long as you know 2 other sides. So look at the first one. Let's make some notes. Find the missing side. I want you to start training yourself to draw an arrow from the right angle to the hypotenuse every time. And trust me, there's a reason for that with where we're going with this. Train yourself to draw an arrow from the right angle to the hypotenuse. That's going to help you remember that that is the longest side, which means when you're going to the Pythagorean Theorem, it has to be plugged in position of which letter? C, which in this case it is the letter C. Got her. Didn't you collect her phone?
Yep, sure did.
Did you put your phone back after
I
lunch?
sure did.
Or not lunch, but
I did. You can go check.
plug the sides in. So this would be 3 squared plus 6 squared equals c squared. The idea is to solve for c. The chair squeaks. The idea is to solve for c. Go to your calculator and enter 3 squared plus 6 squared and see what you get. 45?
It's really easy.
Well, then do it.
And then 45.
All right, now, how do we undo something that is squared?
Square root.
Okay, we're going to square root both sides. And now you should be in a very comfortable situation because of the Delta Math assignment we just did. This is exactly why we practiced breaking down radicals before we did this. You know where this is going. That root 45 needs to be broken down. Write your list of perfect squares somewhere on your paper. Go to the very top of your notebook paper. Write your list of perfect squares and start breaking 45 down. Oh, no, you make it. You do it. All right, ready? 1 squared. 2 squared. Yeah. Write your list. Then start dividing. Find the perfect square that goes into 45. There is one, and it's 9. So we're going to break this into the square root of 9 times the square root of 5. And what is the square root of 9?
3.
So the answer is 3 square root 5. Okay, go to the next triangle. Let's set it up.
196.
Draw an arrow from the right angle to the hypotenuse. That's going to be what goes in position of C. Fill the other sides in. So this is going to be 5 squared plus a squared equals square root 43 squared, right? Don't overthink this. What's the opposite of square rooting? Squaring. What's the opposite of squaring? Square rooting. So right here, when you have a radical as a side length, and you plug it into the Pythagorean Theorem like this, it feels like it's going to be really ugly. It's actually really pretty because they cancel, and you're left with just that 43. It doesn't actually change. So this would be 25 plus a squared equals 43 because those cancel. Now subtract 25. What's 43 minus 25? 18? Yeah. Now we're ready to take the square root of both sides. There you go. 9 and 2.
Non-radical 2.
And no. Take the square root of the 9. There you go.
3 radical 2. I'm sorry. I keep multiplying.
No, you're fine.
Keep multiplying. I shouldn't be sorry.
Huh? Yeah. Y'all try the next triangle. It works out nice.
It worked out nice. Like that.
Did you find that crap?
Go first.
I found all this crap. Hold this.
Hold on.
That's negative 40.
Is it?
No,
Oh, wait, that's the exact answer.
So maybe you didn't find the crap right.
Well, it's negative 40, but it has 81 minus this. You did something wrong. It's 81 is 9 squared minus 4 times, which 4 times 9 is negative 40.
B squared minus 4AC. What's that number? Is that pretty? Oops. Oh, it's pretty.
No,
It's just massive numbers.
not pretty.
Oh, this is the pin viewer
I
stuff.
got two radical lights.
It is.
Oh, I love this pen. So I probably
I got two radical.
Why did it come from 44? Yeah, I think that's right. Yeah. Try the next one.
Okay.
Go get square root 44, which breaks to 2 square root 11. Go to the next one. If you didn't get it, I'm going over it right now. That's a song from when I was growing up, and you hear that song, you just do the whoa, 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 whoa. Like,
That's enough for today.
Yeah.
That's all I got to say. Was that this class yesterday?
225 minus 100 is what? Help me out.
How do you get
That's-
That's 144.
That's 144. I just wanted to know if y'all were paying attention. All right, square root it. You get 4 and 11. Yeah. All right. Next one. Don't panic. Set it up. So you've got, now it's going to get crowded. You've got 2 square root, square root 3 squared plus square root 5 squared, squared equals C squared. Now this one's slightly different because where's that 2 in the parentheses? It's on the outside of the square root, which means it doesn't actually cancel, it does get squared. So you have to think about it. This would be 2 square root 3 times 2 square root 3. So that would be 4 square root 9. Imagine it.
No, it's not.
2
No, it's
square root
6.
3 times 2 square root 3
Equals 12.
would be 4 square root 9. And square root of 9 is...
What? 3. Okay.
And 4 times 3 is what?
12.
The beautiful thing is, if you go to your graphing calculator and you type 2 square root 3 in parentheses and square it, it'll tell you 12. So if you get nervous because of the radical, type it in and check yourself. So this becomes 12. What happens here? Cancels. So we got 17, and I love these because now we're done. Like that, there's nothing else you can do. Because square root of 17 does not break down.
Yes.
All right, look at the next type of problem. Look at the next type of problem. Determine whether the given side lengths form a right triangle. That means this is yes or no. You have to look at the 3 numbers and determine which one's the hypotenuse. Then you just plug them in and check the left with the right. 4, 7, and 11. Clearly the 11 has to be the hypotenuse. So plug it in. We got 4 squared plus 7 squared equals 11 squared. Go to your calculator. 4 squared plus 7 squared is 65. Does 65 equal 121?
No.
Where did I get 121?
11 squared.
Thank you. No, they do not equal, which means no, this is not the side lengths of a right triangle. You do the next one. Like this one right here.
Hey, you told us blackboard once, like 5 plus or minus the square root of the 4. You have to do two separate things.
You do. This is your C. 21 squared plus 72 squared equals 75 squared. Did you get
5,625.
on both sides?
Yep.
So because they do equal, then the answer here is yes. Alright, go to the next one. You don't know off the top of your head what the square root of 10 is, so go to your calculator and type it in and see the decimal, and you'll confirm that 24 should be C. Does that make sense? Double check you should know square root of 10 can't be bigger than 24. But double check it, type it in, the decimal will let you know where it stands. So 24 is going to be your C, so plug it in. 3 squared plus square root 10 squared equals 24 squared. So that's 9 plus 10. 21 squared is 576. Is there any way that that's going to equal? Do I even need to add the 9 plus the 10?
No.
No. Do the next one.
What's 9 plus 10 is
21.
2 square root 10. Type that in your calculator and make sure it's not bigger than 11. It's not. So 11's your C. Alright, so here we go. 9 squared plus 2 square root 10 squared equals 11 squared. So that's 81. Now be careful here. Type it in your calculator if you need to. That's 2 squared, which is 4, times 10, which is 40, right? And then that's 121 equals 121. So the answer is yes. I'm going to show you this last problem so that I have it in the video. Did y'all know that televisions are measured by the diagonal? Some people think a television is measured like by the length of it, which you should know can't be true, because if you've ever seen a 17-inch television, which you probably haven't, it looks really small. If you've seen a 60-inch television, it is not 60 inches long, it's 60 inches in diagonal. So right here is a right triangle. This is saying if the diagonal of the TV is 52 and the width is 40, what's the height? So the height we don't know, the width is 40, and the diagonal is 52. What would I use to solve this?
40 squared.
No, I mean what theorem?
Oh, Pythagorean.
The Pythagorean Theorem.
Whoa!